And welcome back for part 4 of the Unit 13 notes on acids and bases. Same objectives. If you really want to read those, then pause. Okay, we're going to be looking now at some acid-base reactions. These are also called neutralization reactions because an acid and a base, if you put them together, they neutralize each other. They cancel each other out. And if you think back to some of the different definitions that we've looked at, both the Arrhenius definition and the Bronsted-Lowry definition, that kind of makes sense because if you've got a hydrogen and a hydroxide, well, they're going to react with each other to form water. Well, if you've got a proton donor and a proton acceptor, then that's going to, well, I'll just let you watch. Let's just not get to that before we get to that. Neutralization reaction, like I said, it's a reaction where an acid and a base react to produce a salt and water. Now again, this word salt doesn't necessarily mean table salt. Okay, a salt is just an ionic compound of a metal and a nonmetal. So if you take a look at this reaction here, here's HCl, that's our acid. Here's NaOH, sodium hydroxide, that's our base. Now look at what they form. The hydrogen and the hydroxide come together to form water. They cancel each other out. What's left over is the sodium and the chloride. They come together and they make sodium chloride, which in this case is the real table salt. But you can see that's only the case because this guy had sodium, this guy had chlorine. If they had different metal and nonmetal ions, you'd get a different compound. You'd get a totally different salt. So there's your general formula. An acid plus a base yields a salt. Again, put that salt in quotes. It's not exactly the same thing as salt, and water. Look down here. Here's acetic acid. You've got hydrogen and you've got the acetate ion. Here's sodium hydroxide again. You've got sodium and the hydroxide ion. Well, again, hydrogen and hydroxide are going to get together and make water. You've got sodium and you've got acetate. So you stick those together and now you've got sodium acetate. This becomes your salt. Okay? Different salts have different properties. Of course, you already know that this one right here tastes salty. It's white. It's crystalline. It's great in food. It's bad for your heart if you get too much of it. Other salts, like potassium chloride or magnesium chloride, some of those can actually be used as salt substitutes. They have a little bit of a salty flavor, but they don't have exactly the same negative health effects. Now take a look here. Both hydrochloric acid and sodium hydroxide are what are known as a strong acid and a strong base. So when a strong acid and a strong base get together, they end up making a neutral salt and then water. Down here you've got acetic acid though. This right here is vinegar. Sodium hydroxide is your strong base. So in this case, if you have a weak acid and a strong base, it's going to end up making a basic salt. This has basic properties. It can still absorb hydrogen ions. Okay? It doesn't always mean that you're going to end up with a pH of 7. Okay? If the acid is stronger, then your salt is still going to be fairly acidic. If your base is stronger, your salt is going to be slightly basic. Now, in your everyday, you run into this kind of thing. If you've had a little too much food and your stomach starts making a little too much acid, you start getting heartburn, you can take an antacid, okay, which is a substance like calcium hydroxide or magnesium hydroxide, or I think there's an aluminum hydroxide that's in Rolaids, and they will help to neutralize that stomach acid and make it less painful for you. Of course, if you're growing anything, certain plants only grow at a certain pH, and so you can either add acids or bases to change the pH to either bring it up and make it more basic or bring it down and make it more acidic. The way that caves, if you've ever been inside of a cave like in Carlsbad Caverns, you see these really massive things coming down off the roof, these stalactites and these stalagmites growing up from the bottom. What's happening there is that those are literally being carved as sulfuric acid and other acids take some of the calcium from the stone around there and then redeposit it as they evaporate. You get salts build up in your kidneys if you have, well, for a number of reasons, but those are insoluble salts that your body can't get rid of, and so you end up with a kidney stone, which is a very, very painful thing, I've been told. Your body also uses neutralization like this in your blood. You have what's called a blood buffering system, which keeps your blood from becoming either too acidic or too basic. Milk of magnesia, mentioned this in the last video. This is magnesium hydroxide. It helps to neutralize stomach acid. It's been around for a very, very long time. If you get bit by an insect, there's a few different... Ah! Get it off me! Ah! It's true! Ah! This guy. Okay, a wasp. Gosh, you know what? I'm sorry, hate's a strong word, but I hate wasps. Whenever wasps sting you, they have a poison that is basic, so you can take some of that sting out by treating it with something acidic to neutralize it. Says thinking guy. We can use lemon juice or we can use vinegar, which are both some weak acids that you probably have around the house, to help take the sting out of a wasp bite, or out of a wasp sting. Ah! Ants. Their bites are full of acid. Interestingly enough, the Latin word for ant is formica, and the acid that they use is what's called formic acid, okay? And it's named after the ants. Yeah, nobody cares. Since they have acidic bites, you can use a household base. Can you think of any? Like maybe baking soda or possibly bleach. If you have a little bit of household bleach, be careful with that stuff because it stings. But that'll help you feel... Look at this guy. Yeah. What now, wasp? Of course, acids neutralize bases, just like bases neutralize acids. It's a two-way street. They always produce a salt of some kind and water. Okay? Way back when we talked about the different reaction types, one of those reaction types, double replacement reactions, a special subcategory of those double replacement reactions were neutralization reactions, where you have an acid and a base. You always get water as one of your products, and the other substance you get is your salt. You have to be careful, though, because if I have just a little bit of acid and a lot of base, and I put them together, I'm not going to get complete neutralization. There's going to be a lot of base left over, or a lot of acid if I go the other way. A few common salts, of course, you've got sodium chloride, which is just table salt. You all know that one. Here's a few others. Sodium nitrate is made from sodium hydroxide and nitric acid. Sodium bicarbonate is made from sodium hydroxide and carbonic acid. That's baking soda, sodium hydrogen carbonate. Potassium carbonate is made from potassium hydroxide and carbonic acid. And then ammonium chloride is another one. It's made from, I believe, ammonia and hydrochloric acid. So there you go. Uh-oh. A salt in this context, remember, is an ionic compound made of a positive, usually a metal ion, and a negative, usually non-metal ion. Now, when can a salt conduct electric current? What do you have to do to it to conduct electricity? Anybody remember? And there's a special name for that. And we're done. Gosh, we are getting so close. We're more than halfway done. Thanks for watching.